Good day, students. Welcome to lesson 1.1. We're going to be going over lines and graphs in this clip. So let's go ahead and write down the instructions for question number 1. Okay, so for question 1, instructions are as follows. For the given pair of coordinates, for the given pair of coordinates, we're to do the following. A, we are to write the equation of the line through the given points in point slope in point slope and slope-intercept forms. Okay, and then after doing that, secondly, we are to graph the equation indicating the intercepts and then lastly we are to graph the original points of the problem that I'm about to provide to you. So graph the original points and state your conclusion. All right. So for problem number 1, we're going to be dealing with the coordinate pair, which are -4, 1, and 2, -2. All right. Okay, so part A, we have to write down the equation of the line in point slope form first. The point slope formula, let's write down what that is again just to refresh our memory. The point slope form of the equation of a line is y minus y1 equals mx minus x1. Okay? Alright, so in order to use this form, we need 3 pieces of information. We need x1, y1, and we also need m. Okay? So we already know what x1 and y1 are. This is x1 right here. This is y1. And guess what? This is x2 and y2. So we know x1 and y1. x1 is -4. X1 is -4 and y1 is 1. But we do not know what m is. We need to find m. So in order to find m, we need another formula. We need the slope formula. So what is the slope formula? Let's see. The slope formula m, so let's include that. Slope formula is m equals y2 minus y1 over x2 minus x1. So that's what we need to employ to determine what the slope is. Alright, so let's use that to find m. Y2 is -2 minus y1, which is 1, over x2, which is 2 minus x1, -4. Simplify that. -2 minus 1 is -3. 2 minus -4, 2 minuses. You multiply them, you have a plus, slash and dash. 2 plus 4 is 6. If you reduce this by dividing the numerator and the denominator by 3, you're going to end up seeing that your slope is -1 over 2. Alright? Okay, so we have all the information we need to write down the equation of this of the line through these points in this point slope form. So it's going to be y minus y1, y1 is 1, equals the slope m, -1 over 2, times x minus x1, minus x1 is -4, don't forget the sign. And it looks like this form needs further simplification because of this 2 signs here. So we have y minus 1 equals negative 1 half times x minus times minus is plus 4. And this is the point slope form of the equation of the line through the points that were given. Okay, so let's box this as the first answer. And then let's indicate what type of form this is. This is a point slope form. And we see why this is a point slope form because this form easily tells us what's a point on the line, namely negative 4 and 1, and also the slope of the line, which is negative 1 half. All right. We're also asked to express the line in slope-intercept form. So let's write down what the general slope-intercept form is first. So the slope-intercept form, a form that easily tells you the slope and the intercept, y-intercept, is given by y equals mx plus b. Okay, so all we just have to do is simplify the point slope form, isolate y, and the resulting form will be the slope-intercept form. Okay, so let's go ahead and do that. So I'm going to rewrite my point slope form, y minus 1 equals negative 1 half x plus 4. All right, so let's simplify and isolate the y. To simplify, I'll distribute this negative 1 half to these two terms on the right parenthesis here. So we're going to have y minus 1 equals negative 1 half times x is negative 1 half x. And negative 1 half of 4 is negative 2. To isolate y, we'll add 1 to both sides. So we have y equals negative 1 half x plus, minus 1, because minus 2 plus 1 is minus 1. All right? So what we have now is the slope-intercept form of the equation of a line. Okay? So let's indicate what form this is. This is a slope-intercept form. Because in this form, we can easily tell the slope is negative 1 half and the y-intercept is negative 1. All right, now the B part, we are instructed to graph the equation. We have two choices here. It's easier to graph the slope-intercept form because we can easily graph the intercept and apply the slope to get the next point, and then we graph our line, okay? So I'm going to be using the slope-intercept form to generate the graph of my equation. So y equals negative 1 half x minus 1. We want to draw the graph here. That's our objective. All right, so I know the slope, which is m, is the coefficient of x in the slope-intercept form, which is negative 1 half. What does this mean? This means that we're rising by negative 1, which is a drop of 1, and then we're running 2 units. Okay, you always run to the right. Rise could be up or down, but run is always to the right, okay? All right, and then our y-intercept. Our y-intercept, b, is negative 1. Okay? So this B basically indicates where you begin on the y-intercept, all right? So that's how we're going to graph it. Okay, so let's draw a coordinate system. There goes my y-axis, and there goes my x-axis. Let's label the coordinates. This is my x-axis. I'm sorry, label the axis, I meant to say. X-axis, and this is my y-axis. Okay, so let's start by graphing B. Speaking by graphing the y-intercept, which is negative 1 on the x-axis, so negative 1 right here. Let's graph that. That's the first point. And to get the next points, because we need at least 2 points to define a line, we're going to rise negative 1, which is go down 1 and run 2, 1, 2. So those 2 points define our line, okay? All right, so what we're going to do, let me include more points. So go down 2 over, I'm sorry, go down 1 over 2, and then do the reverse here. Just graph more points so that we can have a nice perfect straight line, okay? All right, so let's draw our line through the given points, and that will be the line that represents the equation that we just determined in point slope form and slope intercept form, okay? All right, so there goes your line graphed. Put in the arrows to indicate that they go on for eternity. And then let's label our line. This line is a line with the equation y equals negative 1 half x minus 1. Okay? We are also asked to state our intercepts. Okay, so this intercept, the point where the line intersects the x-axis is known as your x-intercept. X-intercept. All right, your x-intercept here is x equals -2. All right, and then our y-intercept is the point where the line intercepts the y-axis. So that goes a point. So let's label that. This is our y-intercept. Y-intercept. Our y-intercept is -1. Okay, y equals -1. All right, so there goes intercepts. And in part 3, we were asked to graph the points um, of the original problem on the coordinate system and state our conclusion. So the 2 points we're given were -4, 1, and 2, -2. So let's graph those points. If they fall on this line, that means that our results are correct. If they don't, then we have a problem. Okay, so the first point is a -4, 1. So 1, 2, 3, 4, -1. So it goes the first point. That's -4, comma 1. And then the second point is -2, 2. So -2. I'm sorry, 2, -2. So go 1, 2, -2, 1, 2, right there. So there goes the second point. Let's graph it. Indicated 2, -2. Okay. So what is our conclusion? What can we conclude here? So conclusion is since the 2 points fall on the graphed line, line, um, our our graph is correct. Okay. Now, had it been that one of the points didn't fall on the same line with the other point, then we'll know that we made a mistake somewhere, and we have to go back and fix the work. Okay, so that's that for question number 1. Now let's move on to question 2. All right, so let's take a look at question number 2. So the instructions for question 2 are as follows. Um, for the given linear equation, for the given linear equation, let's call this L1. Okay, so let L1 be defined by the equation 3y minus 2 times the quantity 2 minus x equals 2. We're going to do the following. We're going to find uh, the slope and intercepts, the x and y intercepts. And then for the b part, we're going to write the equation of the line L2. L2 is going to be parallel to L1, and it and goes through the point 3 comma 2. And then for the c part, we're going to write the equation of the line, write the equation of the line L3. In this case, it's perpendicular to the original line L1, and goes through the point -1 comma 2. Okay. All right. So let's start out with the a part. Let's find the slope of this equation. All right. Now, to find the slope, I want to express this equation in slope-intercept form. Okay. So if I express it in slope-intercept form, it's easy to determine what the slope is because it's going to be the coefficient of x. All right. So let's put this equation in slope-intercept form. To do that, we're going to try and get y by itself. So let's simplify and then isolate y. I'll distribute -2 to these two terms in the parentheses first. So that yields 3y minus 4 plus 2x equals 2. And then I can add 4 and subtract 2x from both sides. So that gives me 3y equals negative 2x. And then we add 4 to 2 plus 6. And then to isolate y, you divide every single term by 3. If you divide every term by 3, you have y equals negative 2 over 3x plus 2. Okay, so this is the slope-intercept form of this equation. Now we need to find the slope. So the slope, which is m, is basically negative 2 over 3. All right, so there goes our first answer. Let's call it m1. And then we need to find the intercepts. What is this? 2 is the what intercept? That is the y-intercept. Okay, the y-intercept, remember, is b, is given by the number 2. Okay, so how do we find the x-intercepts? To find the x-intercept, all we simply do is set y to 0 and solve. Okay, so let's do that on the side right here. So find x-intercept. This form doesn't make the x-intercept explicit. Okay, so find x-intercept, set y to 0 in this equation. All right, so if we do that, we have 0 equals negative 2/3 x, negative 2/3 x plus 2. All right, so to isolate x, we just subtract 2 from both sides. So that gives us negative 2/3 x equals negative 2. And then multiply both sides by the reciprocal of 2/3. The negative reciprocal of 2/3, so multiply this by negative 3 over 2. And this by negative 3 over 2 also. So this cancels out. Here we're going to have x equals, and then the 2's cancel out here, negative 3. Okay, x equals negative 3 is your x-intercept, so your x-intercept is negative 3. Notice if we set x to 0 here, that'll give us y equals 2, which is a y-intercept. Okay, so these are the answers for part A. Okay, now let's move on to the next question. We are to write equation of a line that's parallel to the given line and goes through the points 3, 2. Okay, so for part B, we know that L1 is parallel to L2. Okay, so if L1 is parallel to L2, what does that tell us? So let's write down a mark. If L1 is parallel to L2, then that implies that the slope of line 1 is going to be equal to the slope of line 2. Okay, so remember line 2 goes through the points 3, 2. So M2, the slope of the second line, is going to be the same as the slope of the first line, which is negative 2/3. All right, and then we also have the point. The point is 3, 2. So this is going to be x1 and y1. All right, so in order to write down the equation of a line, we need a point and a slope. So we have the point and the slope. So we're going to plug it into the point slope form of the equation of the line, which is y minus y1 equals mx minus x1. So let's plug it in here. So we're going to have y minus y1, which is 2, equals m, negative 2/3, x minus x1, which is 3. Okay, so this is the equation of L2 in point slope form. So let's go ahead and write it in slope-intercept form because we're going to be graphing it later. Okay, so to write it in slope-intercept form, we just basically get y by itself. So we have to distribute 2/3 to these terms on the right. So we're going to have y minus 2 equals negative 2/3 x. And then when you distribute negative 2/3 to 3, the 3's cancel, so you're going to have positive 2. And then you add 4 to both sides. Add 2 to both sides, so you have y equals negative 2/3 x plus 4. Okay, so L2 is given by this form, or in slope-intercept point slope form, y minus y1, y minus 2 equals negative 2 third x minus 3. Okay, so this is L2. All right, let's go ahead and do the third part C. We're gonna deal with the line parallel perpendicular to L1. So in part C, L3, the third line is perpendicular to L1. So what is the relationship between the slope of perpendicular lines? So if L3 is perpendicular to L1, then M3 is going to be the negative reciprocal of M1. Okay? So since M1, we found out before, is equal to negative 2 thirds, then M3, which is going to be the inverse, the negative reciprocal of 2 thirds is 3 over 2. Okay? So the point, a point in L3 is negative 1, 2. So we have this point and the slope, x1, y1. Now let's write down the equation of the line. So that's going to be given by y minus y1. Y1 is 2 equals m x minus x1 minus negative 1. Okay? Simplify that further. We have y minus 2 equals 3 over 2 x plus 1. So this is the point slope form of L1. In slope-intercept form, we just simplify this, distribute the 3 over 2. So we have y minus 2 equals 3 over 2x plus 3 over 2. And then to get y by itself, we add 2 to both sides. So we have y equals 3 over 2x plus 3 over 2 plus 2 over 1. Okay? So now we just combine these two, find the LCD times this by 2 top and bottom. So our slope-intercept form is going to be y equals 3 over 2x plus 4 plus 3, 7 over 2. So there you have it. Okay, so L3 is basically this in slope-intercept form, or y minus 2 equals 3 over 2x plus 1 in point slope form. All right, so there goes the answer for part 3. Okay. All right, so let's take a look at part D. Part D, we have to graph all the lines and state a conclusion. So let's go ahead and list all the lines that we're graphing. So line 1 is defined by the equation y equals negative 2 thirds x plus 2. Now what does this tell me? Well, this equation tells me that the slope of L1 is, let's call it M1, the slope of L1 is negative 2 over 3, which means I'm going to rise negative 2, which is equivalent to going down 2 units and run 3. And then the y-intercept of line 1 is 2. Okay? All right. And then for L2, we arrived at the slope-intercept form of y equals negative 2 thirds x plus 4. And what does this tell me? It tells me that the slope of line 2, M2, is negative 2 thirds, which means we're going to rise negative 2 down 2 units and run 3. And then the y-intercept of line 2, B2, is 4. And then for line 3, we had y equals 3 half. We have x plus 7 over 2. Okay? And this means that the slope of line 3 is 3 over 2, which means we're going to rise 3 and run 2. And then the y-intercept, B3, of line 3 is 7 over 2. Okay? All right, let's go ahead and graph all these three lines on the same coordinate system and then state our conclusion. Okay, so now if you notice, one of our y-intercepts has 2 in the denominator, so that should affect my calibration of my y-axis. So instead of going by ones, let me calibrate by 2's on my y-axis to compensate for that fractional component of B3. All right, so 1, 2, that's 1, 2, 3, 4. Okay, 1, 2, 3, 4. I went as high as 4 because that's the biggest y-intercept I have here. And on the x-axis, 1, 2, 3, 4. All right, so this is my x, this is my y. Okay, let's graph line 1. For line 1, b1 is 2, so the y-intercept for line 1 is 2. Let's graph that point. 2, and then we're going to rise -2, go down 1, 2, and run 3, 1, 2, 3. So these 2 points define line 1. Okay, I'm going to draw line 1 using the red line. Okay. All right, so basically draw a line through the points. Shoot that point like that. Make sure it's as perfect as possible. All right, so there goes line 1. If you want to make sure your graph is correct, you can use multiple points. So like we went down 2 and over 3, we can go up 1, 2, and back 1, 2, 3, just to have more points. The more points you have, the more accurate your curve is, okay? So that's line 1 we just drew there. Now what we're going to graph next is line 2. So let's label this. This is L1. All right, line 2, let's graph this one in green. The y-intercept is 4, so start from 4. We have a rise of -2, so we go down 1, 2, and over 3, 1, 2, 3. Okay, you notice that these two lines have the same slope. Okay, so we went down 3, forward, down to 4, 3, so we can go up 2, 1, 2, and back 1, 2, 3, just to have another point of reference. Okay. All right, so now let's go ahead and draw the sketch the line. Let's make this one green. All right, so graph a line through the points. That will be line 3. Okay, I mean line 2. I'm sorry. So there goes line 2. All right, now we're going to go ahead and graph line 3. Let's label it first. So this is L2. Okay. And then L3 has a y-intercept of 7 over 2. Now that's messy to graph. 7 over 2 is the same thing as 3.5 in mixed numbers. So where's 3.5 is right here. How about we graph this in blue? So this is 3.5. So we're gonna rise 3 and then run. We're gonna let's see. We're gonna rise 7 and then run 2. Okay, rise 7 units and then run 2. All right, so if I rise, I'm sorry, we're gonna rise 3 and then run 2. Okay, rise 3, run 2. So we can go 1, 2, 3, and then run 1, 2. Okay, if you have a difficulty end up outside the graph, you can do the reverse direction. Instead of going up 3 and over 2, you can go backwards. You can go down 1, 2, 3, and go back 1, 2. Okay, you're gonna end up at another point that's on the same line. So rising 3 and running 2 is the same thing as falling 3 and backing up 2. All right. So there goes line 3 right there. Let's go ahead and sketch the line. Let's make this one blue. All right. So there goes line 3, L3. Okay. All right. So now what we're going to do is we're going to just put some geometrical marks on them just to indicate the relationship between the lines that can also aid us write down an appropriate conclusion. All right, so let's see. This is L3, line 3. Okay, if you notice, these two lines are parallel. L2 and L1 are parallel, so this line is parallel to this line. And what do you know about L3 and L1? They're perpendicular 90 degrees to that and that. Okay, so what conclusion can we state from the graph? Conclusion, from the graph we can clearly see that lines 1 and 2 are parallel. Lines 1 and 2 are parallel. Lines 1 and 3 are perpendicular. L2 was supposed to go through the point 3, 2, right? But is that the case? Where is 3, 2? Let's see if L2 goes through 3, 2. So 3, this is 1, 2, 3, and then go up 1, 2, bam. This is 3, 2. L2 L2 goes through 3, 2. It's a requirement. If it didn't go through 3, 2, that means our graph is wrong. And another requirement was for L3 to go through what? L3 was to go through negative 1, 2. Is that the case? Negative 1, and then up 1, 2. Bam. Perfect. L3 goes through the point negative 1, 2 also. Okay? So L3 goes through um, um, negative 1, 2. Since all this work, that clearly shows that our answer, our graph is in fact correct. All right? So there you have it. Well, thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel by clicking up here, and please post the comments to tell me what you think about this clip. More clips can be found on map2serve.com. Thanks again, and have a wonderful day.